Hello, friends. Today we're back with another physics lesson. We've been given this problem from one of my viewers. We've got a book on a surface. It's connected with a rope to a coffee mug, and we're trying to see here. We got two parts to this one. We got to see how far does the book slide, and does it stick once it hits the um, top of its motion here. So it's sitting there, somebody pushes it, and then we're seeing what happens once it stops and how far up does it go. So with these tension problems, most important part, you got to draw the free body diagram. And it's the biggest aspect. If you don't draw the free body diagram, it's just not going to work. So let's get right into it. Put that over there. Save that for later. We're going to start, we'll just lay out the important things here. Important equations we're going to need, really, it's just going to be our delta x equals our vi squared over 2a. It's really the only one we need here. Free body diagram, we've got slanted slope. We'll make that blue. So then we'll draw in our book, make that a book-shaped book. Uh, Pulleys, I like to draw them as a little curve. I don't know why, just do. We'll make our mug. We'll draw it like a little square with a handle. That mug doesn't really matter for this problem, but we'll give it an arrow upwards and an arrow downwards. It's got force gravity applied, and it's got force tension in the rope. On the book, the mug applies force tension. So then on the book, we have the force of gravity. It's the big important one. It's going straight down. And then we're going to take that and we're going to draw normal force. Also very important. Force normal. And when we're starting, the book is moving in this direction. So when it's moving upwards, we have motion. So we're starting with our kinetic friction. And we probably should write those down real quick. U sub k equals to 0.2, U sub s equals to 0.5. So when we're starting in kinetic friction, because it's moving upwards, our kinetic friction is going to be facing this ways. So this is going to be our force. We'll just call that U sub k, just UK, Brits. And then, yeah, that's all for our free body diagram. Now from that, we are going to, I just like to draw this little triangle. And that shows us where we got our force normal and our force gravity y. We're just going to imagine this as a tilted axis, basically. So we're going to say this is x, this is y. So we can call this force gravity y. We call this force gravity other way around. Force gravity x, force gravity y. So we can say that this is going to be equal to force gravity times the sine of 20. And that's coming from this is our hypotenuse right here. And that's just going to be times the sine to get that force gravity there. And then this is going to be equal to force gravity cosine 20. And I've already calculated those. So this one is equal to 3.7, and this one is equal to 10.13. So currently the only force acting upwards that would cause normal force is our force gravity y. There's nothing else pulling it downwards. So we are going to say force normal is equal to 10.13. And from that, we can say our force U sub k, I'll put it up here. So k is equal to our force normal times U sub k, which is going to be equal to 2. 0. So that's just 10.13 times 0.2. It's close enough. Anyways, force U sub k, 2.0. Get over it. Force tension now. The coffee cup is 0.5 kilograms. So that times 9.8 gives us our force gravity, 4.9 newtons. Now that just gets translated straight up into tension. So force tension here, 4.9 newtons. So those are all the important forces. So now we are going to get right along to writing sum of forces in the x direction. So we're going to say, because we set this as our tilted axis, we can say our force tension is negative, so we're going to have minus 4.9. Our force static, also negative, minus 2.0. Our force gravity, also negative, minus 3.7. And you're supposed to do that. I don't know why. And so those are all the three major forces, right? We got force tension, force kinetic, and we've also got our force gravity, and that's going to be equal to our mass times our acceleration. So mass of the system here, right? That's what we're going for. So mass of the entire system is the book, so 1.1 kilograms. Kilograms plus the cup, 0.5 kilograms. And that is going to be equal to 1.7, nope, 1.6 kilograms. So we take all of this, and we're going to go negative 4.9 minus 2.0 minus 3.7 all over our mass of 1.6, and that's going to equal the acceleration. So let me calculate that real quick. So we got negative 4.9 minus 2 minus 3.7 over 1.6. So we've got an acceleration equal to negative 6.6, we'll call that 6.63. So that is our acceleration in meters per second squared. So now from that, we need to solve how far does the book slide? And remember I said earlier, this equation would be important. So velocity initial, we see from the problem it was 3 meters per second squared. So delta x equals to 3 squared over 2 times negative 6.63. And when we calculate that out, we get, let me calculate it, oh gosh, 3 squared over 2 times 6.63. So we get a distance of 0.68 meters. So that's how far the book's going to travel up, which, yeah, that seems reasonable. Anyways, that's the answer to A. Now for B. What changes for B is our force u sub k. It becomes force u sub s. We'll change this to red. And it switches to pushing downwards in this direction. Because now the book is trying to go backwards. So the force u sub s is now stopping it. Not that way. This ways. So this is our force u sub s. Force u sub s we can calculate the same way as in force u sub k. Going to be equal to 10.13 times our u sub s, which is equal to This one's equal, say, 5.06. So that's our force u sub s, and that's the only difference. We just gotta put that into our sum of forces equation. Sum of force x is equal to, so then we go, this is still negative. That's our force tension. And then we're going to say plus this time, and that's going to be our force static, 5.06. And then we've got our minus 3.7. That's our force gravity. And this time we don't need to do equals mass acceleration because we're literally just trying to find the net force on our book here. So taking those three forces, adding them up, we get a negative force. And because of how we set up our axes here, a negative force is this direction, which means the book is sliding off the table. And that is all. If you have any more physics problems you need me to solve, send them my way. No problem is too difficult or too easy. Goodbye. Thank you for watching.